Hi there, welcome back to some more drawing. So going to look at isometric projection, okay, or axonometric projection, basically 3D drawing. Okay, so just a reminder on the difference between this type of isometric and the type of isometric drawing you would have done at junior cert. So isometric is made up of 3D, which has vertical lines going at 30 degrees in this direction and lines going 30 degrees in the opposite direction. Okay, so you use your 30-60 set square, set up your your axes and your 30-30 in vertical and start drawing your object. Okay, with isometric drawing, the actual size of the object, the actual measurements, the length, the height, the width, those measurements are used on each of the lines. So if the object, say, was 100 millimeters in width across that way, on that actual line you'd be marking 100. If its overall height was 50, on that line you'd be marking 50. Okay? We note in reality, as we look at objects, they appear to get shorter. So even if the depth of that object happened to be, let's say, 70 millimeters, we note if we're looking at it, that will appear shortened. Okay, so it'll be less than 70. So the measurements in an actual 3D as we look at it, because the lines are running away from us, appear shorter than they actually are. Okay, so that's where isometric projection comes in. Okay, so we're drawing a more realistic 3D view of the object. Okay, so in terms of the way we set up the axonometric, just to give you a quick reminder as to how or why we do it the way we do it. Okay, so I like to think of it as, if we start with the corner of a room, we've got a wall, we've got the floor. Okay, in the corner of the room, we're taking our object and we're basically sticking it into the corner of the room with it sitting on the floor. One surface is resting up against one of the walls, the other back surface is resting up against the second wall. Okay, that object is sitting there in the corner of the room. We are looking into the corner of the room. So if you imagine we are kind of suspended here in space, right, in the room. Imagine standing up on a stool or something like that, or a ladder. You're looking down into the corner of the room so that you can see the wall and the floor, and we see our object sitting in there. Okay, when we look into the corner of the room, rather than taking the full wall, we're kind of, imagine if I draw in a line there in the corner there, from corner to corner, and a line there roughly, and a line down this way. Okay, if you imagine that triangular surface is a plane. Okay, it's a plane which runs along the floor, runs along the wall, runs along the wall. Okay, and on that plane we're sketching our 3D image, or a 3D isometric, on this flat surface here. Okay, so that's a triangular surface. The angle at which we're standing out here in space, on our chair, on our ladder looking into the corner of the room, the angle that we look at is going to affect the shape of this triangle. So if we're equal distance from, if we're straight out from the corner and we're an equal distance from the wall and the floor, this triangle is going to appear as an equilateral triangle. Okay, so that's our basic axonometric setup, where we're going to start with the triangle and the center of our room. Okay, I'll run through that in a minute. If we move ourselves, if we get off our ladder or our stool and we move it further over this direction, and we get back up on it and we look into the corner of our room again, because we're looking at it more of an angle, or it's a different angle, this is no longer going to become an equilateral triangle. Okay, and depending on where exactly we are and where we're looking at that, the shape of this triangle changes. Okay, so it may be equilateral, it may be an isosceles with two sides the same length, or it may be a scalene where the three sides of the triangle are different lengths. Okay, that will affect the angle at which the axes are running at. Okay, so we're going to have our X, Y, and Z axis. Okay, one of them will always be vertical. Okay, so this one will always be vertical. The angle at which this one and this one go at is going to be determined by the question, and it's essentially determined by the type of triangle or size of triangle we're looking at here. All right, and generally you're given the angles for the axis. Okay, regardless of whether it's an equilateral triangle, whether it's a scalene or an isosceles, one thing stays the same always. Okay, we know that as we look into the corner of the room, so if we're standing here where the green arrow is, looking at the green wall, the bottom corner of that wall is going to be 90 degrees. Okay, if you imagine standing in a standard room on the floor looking at the wall, where the wall meets the floor is going to create a 90-degree angle. So that's why when we project our view of our wall, our true shape of our wall up here, we're going to see a 90-degree angle at that corner. Okay, if I now walk around here as far as the red arrow, I'm now standing looking in for the red arrow at the red wall, okay, where the red wall intersects with the floor and the other wall, I know that that's going to form a 90-degree angle in reality. Okay, obviously at the moment it's not because we're looking at it at an angle, but that's going to form a 90-degree angle. Okay, which is why if we project that over to this space to get its true shape when we set up a elevation or an elevation, we want to set up a 90-degree angle because this in reality is a 90-degree angle. Okay, finally, if we look down from the blue arrow direction, so we're now suspended above the floor looking down, I know that the corner here where the floor meets both walls, in reality, that's going to be a 90-degree angle there. So when I project down the true shape of the floor down here, right, I know I'll be setting up a 90-degree angle because that's what it is in reality. Okay, so we have a 90-degree angle there, 90-degree angle on the floor, and a 90-degree angle there. Okay, and I'm going to run through the setup of that in a minute. So I said, what changes on this question? If I go for a different color. Okay, it's not really going to shade in great here, but that triangular surface there, think of it as a triangular plane, right, on which, like a piece of glass, on which we're going to draw our 3D. Okay, the three axes are the three lines of intersection between the wall, the floor, the wall, and the wall and the floor. Now, I'm referring to these as walls and floors. Essentially, we have a vertical plane and a horizontal plane. Okay, but just to keep it simple, if you want to think of it as walls and floors, doesn't make any difference. It's still going to be the same thing. Okay, so that's just a kind of a brief overview on how this actually works. And what I'll do next is I'll run through the basic setup for a setup where we've got our axis vertical 30 degrees and 30 degrees. Therefore, our triangle here at the center is going to be an equilateral triangle. Okay, and we'll look at how we project out our true shapes. Because we're going to project out true shapes, we'll be projecting true lengths. And then when we project back those true lengths to get our isometric here, those lengths will have been shortened. Okay, which will give us a more realistic or a true view of the object, a 3D. Okay, thank you.